Hey YouTube, this is Mike, and you may know that I have a number of YouTube videos where I show you how to program various casino games. And in the comments, you guys have challenged me to make one for Ultimate Texas Hold'em. And that is asking a lot. Ultimate Texas Hold'em is a pretty difficult game to analyze, but I am up to the task. You've challenged me and I accept the challenge. And because this is such a big game, I'm going to break it down into multiple parts, but I'm going to keep like building off of previous parts and add to them as we go. So who knows how many videos this is going to be, and I could see this going up to like 2 hours long. But let's get started. And the way I'm going to get started is to start with writing code to score any given 5-card poker hand. So first, let's write a program that's going to cycle through all possible 2,598,960 ways to pick, or should I say choose 5 cards out of 52. And let's create 5 variables, C1 to C5, for those 5 cards. And I'm going to do 5 nested loops to choose those cards. So C1 will be the lowest card. C2 will be the second lowest, and that will start one more than whatever C1 was and go up to the card number 48. And likewise, I keep starting each card from where the last one left off. And so what we're going to get when we're in this program is 5 numbers ranging from 0 to 51, and they will all be different. So I hope you're with me so far. And let's create a variable SC for the score. So this is going to call some program score5, or a function score5, which I will write next, that will score this hand. And I'm going to pass to it these 5 numbers ranging from 0 to 51, representing 5 different cards. And I will decide what to do with that score later. But for now, let's create a function that's going to score the poker value of those 5 cards. And I'm just going to call this score5. So it's going to get passed to it these 5 integers. Now, let's convert these 5 numbers from 0 to 51 into 5 different ranks and suits. So let's call the ranks R1 to R5 and the suits S1 to S5. So we're going to say R1 is equal to C1 divided by 4. And so that's going to give us some value between 0 and 12 to represent the rank. And don't worry about dividing equally. When you do it this way, it will round down. And let's do the same thing for the other 4 cards. And then let's do the now let's do the suits. So I'm going to take the modulo of each card to how shall I phrase this? I'm going to still divide it by 4, but take the remainder as the suit. So that's going to give me a suit ranging from 0 to 3. We are now ready to write some code to try to figure out what poker hand these 5 cards are. So let's start with a 4 of a kind. And remember, these cards are in sequential order going from lowest to highest. So if R1 equals to R4, then we have a 4 of a kind where R5 is the singleton. And let me explain to you something I'm going to do here with this program. I am going to give each type of poker hand a number, and a royal flush will be 9, a straight flush 8, 4 of a kind 7, full house 6, flush 5, straight 4, 3 of a kind 3, 2 pair 2, a pair 1, and 5 singletons that aren't a straight or a flush will be a 0. And it's also important what are the individual cards in case we need to break a tie. So for a 4 of a kind, I'm going to return 7, which again is the number for a 4 of a kind, times 13 to the 5th power. And I'll explain why later, but I'm basically using base 13 arithmetic. And then the next important thing with a 4 of a kind is the rank of the 4 of a kind itself. And I'm going to multiply that by 13. And I could pick anything R1 to R4 for the rank of the 4 of a kind. And then finally, I'm going to add the value of the singleton, which is R5. Sorry. And now I'm going to copy and paste that code, because another type of 4 of a kind is when R2 is equal to R5 and R1 is the singleton. So here all we have to do is change the singleton from R5 to R1. So there are our 4 of a kinds. So next let's check for a full house. So one type of full house is when R1 is equal to R3 and R4 is equal to R5. So recall that my value for a full house is 6. So I'm going to do 6 times 371, 293, again 13 to the 5th power, excuse me, 6th power. Plus the next important thing is the rank of that 3 of a kind, which is one of the cards in that 3 of a kind is R3, and then the value of the pair. And let me write a comment here. And that's just one type of 4 of a kind. Another is when R3 is equal to R5 and the pair is R1 and R2. So all we need to change here is the value of the pair. So I'm going to change that from R 4 to R1. Next, let's check for a 3 of a kind. So one way we can have a 3 of a kind is if R1 is equal to R3. In that case, we're going to return 3 times 13 to the 6th power plus 169, which is 13 squared, times R3, the value of that, the rank of the 3 of a kind, plus 13 times the rank of the higher singleton, and then the rank of the lower singleton. So there are 2 other types of 3 of a kinds. The next one is when R2 is equal to R4, and in that case the lowest singleton is R1, and the other type is when R3 is equal to R5. And in that case, the highest singleton is R2, and the lowest one is R1. So notice how R3, the third card, is always in that 3 of a kind. So next, let's check for a 2 pair. So one type of 2 pair is when R1 is equal to R2 and R3 is equal to R4. So then we're going to return 2 times 13 to the 6th power plus 169 times the value of the higher pair, which can be represented with R3, plus 13 times the value of the lower pair, which can be represented as R1, plus the singleton, which is R5. And there are 2 other types of 2 pairs. Another one is when R1 is equal to R2 and R4 is equal to R5, where R3 is the singleton. And to adjust for that, here the higher pair can be represented as R4, the lower pair can still be represented as R1, and R3 is the singleton. And finally, another one is when R2 is equal to R3 and R4 is equal to R5. So here, R5, or we'll say R4 is equal to we'll multiply 13 squared by the R4, which is the higher pair, 13 times R2, which is the lower pair, and the singleton is R1. And next, let's do a pair. So one type of pair is when R1 is equal to R2. In that case, we're going to return 371, 293 plus, and here we need 4 values for, to represent the value of this pair. So first I'm going to do 2197, which is 13 to the 3rd power, times the value of that pair, which can be represented as R2, plus 169 times the highest singleton, which is R5, plus 13 times the value of the second highest singleton, which is R4, and then plus the third highest singleton, which is R3. And there are 3 other types of pairs. 1, 2, 3. The next one is when R2 is equal to R3. So here we need to change the pair can stay the same at R2. The highest singleton is the same, the second highest is the same, but the lowest singleton is now R1. Okay, next let's do the pair where R3 is equal to R4. So the pair is represented by R3. The highest singleton is still R5, and the lower 2 singletons are R1, R2, and R1. And finally, the last type is when R4 is equal to R5. So we need to change the value of the pair to R4, and the 3 singletons are R3, R2, and R1. So if we got this far and we haven't found a poker hand yet that matches the conditions for something with at least a pair in it, then we either have a straight, a flush, a straight flush, a royal flush, or nothing at all. So next let's test for a flush. No, let's start with a straight. A straight is a little easier to explain. Okay, so I'm going to get out of this whole big if statement, and I'm going to create a couple new variables called straight and flush. So let's test for a straight. We already know there's no pair. We know that all 5 ranks are different if we got this far, because we tested for pairs and 3 of a kinds and 4 of a kinds. So one way we can have a straight is a wheel. And there's this annoying rule in poker for programmers where if the player has ace 2, 3, 4, 5, it counts as a straight. So let's test for that. So if R5 is equal to 12, which represents an ace, the highest rank, and R4 is equal to 3, then the ranks must go 0, 1, 2, 3, 12. And we have a straight. So if that happens, let's return. You may recall that the value for a straight is 4. So we're going to multiply 4 times 13 to the 6th power. Plus, we need to add something to show that it's the wheel. And, you know, let's just, let's add nothing at all. If it's just 4 to the 13th power, then it's the lowest possible straight. And you know, we can, let's, no. Let's, I forgot. We're going to say our value for a straight, the variable, is equal to 4 times 371, 293, and that's it. And the other type of straight is when R1 plus 4 is equal to R5. Then you have 5 sequential cards. And if that is true, we're going to say straight is equal to, again, 4 times 371, 293. So the lowest type of straight, other than the wheel, would go 2, 3, 4, 5, 6. So let me think for a second. Okay, so I'm going to add to this the value of the second lowest card. The lowest that can be is a 1, so it's going to be a little bit higher than the wheel straight. And now let's test for a flush. That's going to be pretty easy. So if S1 is equal to S2 and S2 is equal to S3 and S3 is equal to S4 and S4 is equal to S5, then we have a flush. And we're going to say that value of a flush is 5 times 371, 293 plus, and here we need to look at all 5 ranks in case we need to break a flush-flush tie. So I'm going to multiply 13 to the 5th power, which is 28,561 times R5, plus 13 to the 3rd power, which is 2197 times R4, plus 13 squared times R3, plus 13 times R4 plus R5. So that'll give us an exact representation of the poker value of that straight. Otherwise, we're going to say flush equals 0. And I just realized I forgot something. If none of these conditions for a straight are true, we're going to say the value of that straight is equal to 0. Okay. At this point, we have variables that will indicate to us whether we have a straight and if we have a flush. So the highest possible poker hand we can get is a royal flush, and the second highest is a straight flush. So if straight is greater than 0 and flush is greater than 0, then we have some type of straight flush. So let's test first if it's a royal flush. So if R4 is equal to a king, which is an 11, then we must have a royal flush, because R5 would be a 12, and we already know it's a straight, so the whole thing would be a straight. And you might say, why not check if R5 is a 12? Because then it still might be the dreaded wheel. So let me make a comment here. So in this case, we're going to return 9 times 371, 293, the 9 representing a royal flush. And that's all we need to know. A royal is a royal. And you might say, why even bother checking for a royal? Why don't you just return a value for a straight flush? And the reason is there is a bonus in Ultimate Texas Hold'em for a royal, so we need to give it special treatment. So otherwise, we have a straight flush on our hand, and you may recall 8 is the value for a straight flush. And we need to add something for how high that straight flush is. And let's go back to how we did it with a straight and add the value of R2, which must be at least 1. And wait a minute. You know, I forgot also about the wheel, but an easier way to do this will be to just add the value of that value of straight. In fact, that's why I took the trouble to calculate it so exactly. So there we go. That handles our straights and straight flushes and royal flushes. Otherwise, if flush is greater than 0, then we have a flush, and we're going to return hold on. I made a little mistake. Okay, I forgot that I already incorporated the value of the straight here at 4 times 13 to the 5th power. So this is going to be a mistake to add the value of a straight here. So I am going to check for a wheel in much the same way I checked for it with the straight. So I'm going to check that R5 is equal to 12 and R4 is equal to 3. And in that case, I'm just going to return 8 times 13 to the 6th power. Otherwise, we have some other kind of straight flush. And there I'm going to return 8 times 13 to the 5th power plus, how did I do it for a straight? I'm going to add just the value of R2, which must be at least 1. So that should be accurate. So let's go back to our flushes. If flush is greater than 0, then we're just going to return the value of that variable flush. Otherwise, if straight is greater than 0, then we're just going to return that value of straight. Otherwise, we have trash. We have an ace high or less. And here we're going to go back to our this line here that we used for a flush. I'm going to copy that and paste it here. And I'm going to return this value except taking out the 5 times 13 to the 6th power because we don't have a flush. I'm just going to call this trash. And there we go. That should return every kind of poker value. Next, let's write some more code to this score 5 all function, which will cycle through all the ways you can choose 5 cards out of 52 to see if it scored them correctly. And first, let's make an array for the names of the poker hands. So I'm going to call, so the element number 0, I'm just going to call trash, and then a pair, and then 2 pair, and 3 of a kind, and straight, and then straight, and then a flush, and a full house, and a 4 of a kind, and a straight flush, and then a royal flush. And sorry, this is going off the range. Okay. And my apologies to my old computer science teacher, Clint Staley, who hated global variables, but I have a feeling I might be needing this array of hand names later in the program. So, okay, back here, let's create an index called I, and then an array to score how often we get each hand. So I'm just going to call it score array, and then put 10 values in it. And let's initialize it. Okay, and then down here, I'm going to increment the value of score array by whatever the score is. And then down here at the bottom, I'm going to loop through all the poker hands again. This time I'll start at the highest. So I is equal to 9, I is greater or equal to 0, and then I minus minus. And then I'm going to say, first I'll set, let's say the index number. And then, oh, wait a minute, I forgot to do something. Okay, down here, we could get, values up to 13 to the 6th power times 9, which is way more than our array here. So I'm going to divide by 371, 293. So that will get us back to just the classification of the poker hand and forgetting all of the other values of the individual cards. And again, don't worry about the remainder. It's just if this is all going into an integer, it's going to just round down to the highest. It's going to round down to the next integer. So next, let's put out the name of the poker hand. And what did I call that? I called it poker hand. And then the number of times that poker hand appears, or the value for score array. Next, let me do some housekeeping things. I'm going to change the value of the main, the type of the main function to an integer. And next, I'm going to declare these functions that the program uses. score 5 takes in 5 integers, so I'm just going to copy and paste this code and add the semicolon. And so far the program doesn't actually do anything, so let's call score 5 all. And now let's compile it. And just take it from me, it compiled just fine. And now let's run it. And let me bring that window over. So there we go, there's our output, 436, 624, 3744, and so on. And trust me, these numbers are right. I've seen them thousands of times. So I am satisfied that the program is scoring 5-card poker hands correctly. And next, let's score 7-card poker hands, because Ultimate Texas Hold'em is a 7-card game. So let's start by creating a program called Score 7 All. And it's going to be very similar to Score 5 All in structure. And I'm just going to, so I copied and pasted Score 5 All, and I'm going to change the copy to Score 7 All. And I'm going to add 2 more variables for the 6th and 7th card, C6 and C7. And I'm going to add 2 more loops in here. So I'm going to say for C6 is equal to C5 plus 1 up to $50. And I will fix those other loops in a second. And C7 is going to go from C6 plus 1 up to 51. Okay, and let's fix these. So C1 is now only going to go up to 45, C2 to 46, C3 to 47, C4 to 48, C5 to 49, and C6 and C7 are already correctly at 50 and 51. So next what we're going to do is we're going to go through all the ways we can omit 2 cards out of 7 and score all of them and then take the highest value. So let's create another variable, another array, and I'm going to call it the score 5 array. And there are 21 ways we can choose 2 cards out of 7 as those 2 cards to omit. And let's drop this. And let's just remove that line for now. So what this line here is saying is let's omit cards C6 and C7, score these 5, and put it into element number 0 of the score 5 array. And next, for element number 1, we will omit cards 5 and 7. So I'm going to change that C5 to a C6. And for element number 2, I am going to change C4 and C5 to C5, no. I'm going to change C6 to C7. And next I'm going to change C4 to C5, and C7 to C6. So I'm going to go through this systematically. And I'm sure that there's more elegant ways I can do this with less typing, but I'm trying to keep things as simple as I can with this video. So here we're going to go C5 and C7 for the last two. And here we're going to go C6 and C7. And I forgot to change that 4 to a 5. So next we're going to increment this C3 to a C4. And the next two we can be C5 and C6. So here let's change that C6 to a C7. And here we're going to change C5 to a C6, and C6 to a C7. Now we're ready to increment the third position to a C5. Whoops, C5, C6, and C7. Next, we're ready to increment this value of C2 to a C3. So I'm going to grab these lines here and copy and paste them. So here I change this to element 11, 10, 11, 12, and 13. And I'm going to change these C2s to C3s. And now, element number 14, I can increment this C3 to a C4, and the rest is right. So now I'm ready to increment this first value that gets past the score 5 from a C1 to a C2. So I'm going to copy these lines here and update these indexes. And I'm going to change these C1s to C2s. And now there's nowhere to go but to increment the value of C2 to C3. So there we go. We have 21 different ways to pass 5 cards out of 7 to score 5. And if we number 0 to 20, that adds up to 21. So hopefully I did this correctly. So next let's figure out what is the highest of all these values. Let's create a new value called score 5 max. And first we'll initialize it to 0. And now let's make a loop going from I equals 0 to 20. So if score 5 array element number I, and I forgot a parenthesis, is greater than score 5 max then score 5 max becomes that value of score array. So that code will give us the maximum possible score of all these 21 possible values. So let me go down, where was it? Let me go to this program and remember how I did this. So I'm going to increment the value of score array by score 5 max divided by, let me put a parenthesis in here for clarity. So I'm going to divide that by 13 to the 6th power, which again is 371,293. And that should be a score 5 max. Okay. So let's declare this function here. Okay, next let's execute this score 7 all. And just for clarity, I'm going to say I'm going to title this with 5-card poker, and in score 7 I'm going to say 7-card poker, and let's compile this. And it did not like something. Okay, it's telling me that we didn't need this value of score in score 7 all. So let me compile it again, and it worked. And now let's run it. So let me bring this over to here. So you can see it did the 5-card poker hands pretty quickly. And I'm just going to pause this and wait for the 7-card results. So here we go. Here are our combinations for 7 cards out of 52. And just eyeballing it, it looks right. But let me pull up my website, Wizard of Odds. And here are combinations for 7-card poker. And you can go back and forth to check it, but I already did, and this all looks accurate to me. So with that, I consider at least the first task of this program to be done, finding, correctly scoring a 5 and a 7-card poker hand. So I'm ready to move on to the actual structure of Ultimate Texas Hold'em.